Given question, the weight of an electric motor is 125 Newton and it runs at 1500 rpm. The armature weighs 35 Newton and its CG lies 0.05 cm from the axis of rotation. The motor is mounted on 5 springs of negligible damping so that the force transmitted is 1/11th of the impressed force. Assume that the weight of motor is equally distributed among the 5 springs. Determine first stiffness of each spring. Second, dynamic force transmitted to the base at operating speed. Third, natural frequency of the system.
Let us understand given data with the help of diagram. The weight of the electric motor is given. So this is the total weight including unbalanced weight. So this is the capital W is equal to 125 Newton. Now from this we can calculate the value of M. So this capital W is nothing but M into G. So capital M is equal to 125 divided by 9.81 which is equal to 12.742 kilogram. Now unbalanced weight, that is the weight of armature W0 is given and that is equal to 35 Newton. So it is equal to M0G. Now value of M0 we can calculate, that is 35 divided by G, that is 9.81 which is equal to 3.5678 kilogram. Value of E, that is the distance of the unbalanced mass from the center of rotation is given. It is 0.05 centimeter. So standard unit is meter. So we will write here 5 into 10 raised to minus 4 meter. Now this system is balanced on the 5 springs. Now if we observe, all these springs are in parallel because the weight of this machine is equally distributed on the 5 springs. So we have to calculate the equivalent spring stiffness. So because these springs are parallel, so K equivalent is equal to, we have to add all this stiffness, that is 5 times K. So we will write here K equivalent is equal to 5K. Now the force transmitted to the foundation. So this is the machine and here are the springs. Now through the springs the force transmitted to the foundation, that is Ft, is given 1/11 times of impressed force. Now impressed force is the harmonic excitation force because of the unbalanced rotating mass. So we will write here Ft is equal to 1/11 Fo. Now Ft by Fo, that is nothing but transmissibility. So Tr is equal to 1/11. So value of Tr we have to consider here 1/11. Now here the damping is negligible. That means damping coefficient value of C is 0 and that's why damping factor zeta we have to consider 0. Now the speed of rotation is given 1500 rpm. Now from this value we can calculate the value of omega, that is equal to 2 pi n by 60 and which is equal to 157.08 radians per second. Now we will find out the value of R. R is the frequency ratio, so we know that R is equal to omega by omega n. So how to find out this R? Now we have the value of Tr, that is the transmissibility 1/11. So this Tr is equal to Ft by Fo, which is equal to magnification factor ohm in the under root of 1 plus 2 zeta R bracket square. Now what is this magnification factor? So we will write here the formula. 1 divided by under root of 1 minus r square bracket square plus 2 zeta r bracket square. And in numerator we will write 1 plus under root of 1 plus 2 zeta r bracket square. So for this formula, if we observe, it is given that the damping is negligible. That means damping factor is 0. So when we put zeta is equal to 0, then we will get Tr is equal to 1 divided by under root of 1 minus r square bracket square. So value of TR is known 1 by 11. Now when we solve the equation, we will get the value of R. We will write 1 by 11 is equal to 1 divided by 1 minus R square. So we will take here the cross multiplication. So 1 minus R square is equal to 11 and therefore R square is equal to minus 10. So here this is not possible because we cannot take the root for this negative value. So we will make here one modification. We will multiply this with minus sign. So if I take 1 by 11 is equal to minus 1 divided by 1 minus R square. Then again we will cross multiply. So 1 minus R square is equal to this minus 1 into 11, that is minus 11. So if we simplify this, if I transfer this 1 to the right hand side, then minus 11 minus 1, that is minus 12. So minus R square is equal to minus 12. So R square is equal to 12. So we can take the square root on both sides. So R is equal to 3.46. Now this R is nothing but the frequency ratio omega by omega n. So value of omega we have calculated from the given value of n. So omega n is equal to 45.34 radians per second. We will move to the second question. We have to calculate stiffness of each spring. Now if we observe stiffness of each spring is K. So this K is we have to consider for the calculation, that is K equivalent, and this K equivalent is nothing but 5 times of K. So here for this question we have to find out the value of K. So we have to calculate this K. So we know that omega n is equal to under root of K equivalent divided by M, because this whole system is equally distributed on these 5 springs. So we have to consider here equivalent spring stiffness Ke by M, where M is this capital M we have to consider. So which is equal to under root of 5K by capital M. Now we will put the value. So omega n, value of omega n is known 45.34, which is equal to under root of 5K by 12.74. So K is equal to 5239.96 Newton per meter. We will move to the third question. We will calculate force transmitted to the base Ft. So if we observe, here is the system and which is equally distributed on these 5 springs, and the force transmitted to the base, that is Ft. So we have to calculate this. So we have one formula, Ft by Fo, that is Tr is equal to magnification factor Ohm in under root of 1 plus 2 zeta r bracket square. Now if we observe this system, here damping factor zeta is equal to 0. So how we can write this equation? So we can write here, if we put here this term will become 0. So under root of 1, that is equal to 1. So Ft by Fo is equal to magnification factor Ohm. So we will first calculate this magnification factor. We have formula 1 divided by under root of 1 minus r square bracket square plus 2 zeta r bracket square. So here also zeta is equal to 0. So the second term will become 0, which is equal to 1 divided by under root of 1 minus r square bracket square. So we will put value of r and we will get the answer 0.0909. Now we will find out this value of Fo. So this Fo is the force impressed on the system. So this is the harmonic excitation force, and this is due to the unbalanced mass rotating in the system. So how to calculate this Fo? That is equal to m0 E omega square. So m0 we have calculated 3.56 E, 5 into 10 raised to minus 4, and omega 157.07 bracket square. So F0 is 44.01 Newton. Now how to calculate this Ft? So Ft is equal to Fo into this magnification factor, and which is equal to 4.001 Newton.